Write 124 as a product of its prime factors. Okay, there's a couple of things we need to break down here in this question. So we are being asked to write something as a product. The word product means multiply, okay? So we have to show our answer in terms of multiplication signs as a product. Prime, well, I recommend that you learn at least the prime numbers up to 20, which are these ones that I'm going over here. I mean, even better if you can learn a few more. I would say that as a minimum, learn the prime numbers that are highlighted in yellow there up to 20. And then the word factors. So this means numbers that go into another number exactly with no remainder. So they divide exactly into a number with no remainder. Okay, so product means times, prime numbers we've looked at here, and factors is numbers that divide exactly into another number. So how do we do this? Well, we look at the number 124 and we look at some factors. So we're looking at numbers that go into 124. Well, an easy win here would be the number 2. Why? Because it ends in an even number, so I know that 2 must go into it. Now, what do I multiply 2 by to get to 124? Well, if you can't do this in your head, you can just do a little bus stop. 2's into 124, well, 2's into 1 don't go. 2's into 12 go 6 times, and 2's into 4 go twice. So here, the opposite number is 62. So just pausing here, we are looking for 2 numbers that multiply, because of course, remember, we are looking at products, okay? Product means multiply. We're looking for 2 numbers that multiply to give 124. So 2 and 62 are an option there. You can, of course, choose other numbers, and I will show you some of those in a second. So 62 and 2 are an option. Right, before I move on, you need to circle the prime number, if you get one at all, on your little tree here that we're going to do. And I can see here in my grid over here that 2 is a prime number, so I'm going to circle that straight away. And once you have got to a prime number on one of the branches, so to speak, of this prime factor tree, you stop, okay? But I'm going to keep going on here. Now, 62, again, it's an even number, so 2 is an easy win. And I already know that 2 is prime. And I'm going to do 2's into 62. 2's into 6 go 3. And 2's into 2 go 1. So 31 is on the other branch there. Now I can see here that 31 happens to be prime, so I'm going to put a circle around it there. Okay. Now you might think, well, you just said only learn up to the prime numbers up to 20 and 31 is above that. That's true, but what you can do is you can go, okay, well, what numbers do I know that multiply to give 31? Well, let's do some factors. 1 and 31. Does 2 go into it? Well, no, because 31 is not even. Does 3 go into it? Well, you can do your 3 times table, and if 3 goes into 30, then 3 is not going to go into 31. 4, well, 4 would give you an even number, so no, it's not going to go. 5 doesn't go into it because it doesn't end in a 0 or a 5. 6, you can go through your 6 times table again. 6 goes into 30, so 6 is not going to go into 31. So you can try until you've satisfied yourself that there are no factors. You don't have to go very far, and then you can probably confidently assume it is prime. Okay, but what I was saying was, as a minimum, yes, you should learn your prime numbers up to 20. So we have done a product of prime factors here, or sorry, a prime factor tree. What's the final part of the answer is to show 124 as a product of its prime factors. So as a product of its prime factors, I'm only looking at the ones in red. Why? Because they are the prime ones. I'm not actually interested in 62 in this situation. I'm only looking at its prime factors. So as a product, which remember means times, as a product of its prime factors is 2 times 2 times 31. You must show the times sign. Some students make the error of putting pluses or commas. You will lose a mark if you do that. You have to show it as a product, which means you must use the multiplication sign. So this is the final answer. 124 as a product of its prime factors is 2 times 2 times 31. You could also make this more efficient and put 2 squared multiplied by 31 if you are confident using indices. I just wanted to show you another way. If you decided you wanted to divide by a different number, let's go for 4. Imagine if you decided to pick 4 here. Well, just going to clear some space here. Imagine if I divided 124 by 4. Let's just do a little bus stop with 124 and 4. 4s into 1 don't go, 4s into 12 go 3, and 4s into 4 go once. So the other number here would be 31. And you would stop on this branch, but 4 is not prime, so I'd keep going here. And what 2 numbers multiply to give 4? 2 and 2. And now I've got to my primes at the end. So you can see it doesn't matter which numbers you pick initially on your branches, because you will end up with the same thing. So as long as you pick a number, let's say I did here, I did 4 there and I did 2 there, as long as you pick a factor that goes into the number at the top, 124, you'll end up at the same thing, as provided you do it correctly, you'll end up with the same prime factors at the end. So 124 as a product of its prime factors is 2 times 2 times 31.